Question number 11. An object falls from a rest through air. Its velocity increases. You know that velocity and air resistance are directly proportional to each other. When velocity increases, air resistance also increases until it reaches terminal velocity, and we know that terminal velocity is approached when air resistance and weight of the object both becomes equal to each other. Then terminal velocity is achieved, which quantity increases until its terminal velocity is increased. So we have just acceleration actually decreases, resultant force becomes zero, weight remains unchanged, so actually air resistance increases. So the correct option is this one, and rest of the options are incorrect. Question number 12. In question number 12 it says the speed time graph represents a short journey. Which distance time represents the same journey? It means it's a it's a speed and here is a time. So it's a speed time graph, and we have like 4 options which are equivalent to this speed time graph, but those options are in distance time format. So let's see. Okay, so initially you can see, like suppose this is 1 second and speed is 5. In 1 second it is 5. Suppose here is 2 second, because it's a uniform speed graph, so here would be 10. Suppose after 3 second it would become 15. After 4 second it would become 20. So what I mean to say is, during this first interval the speed was small, so during this first second the distance traveled would be small. During this second the speed is doubled, so distance traveled would be much more than this one. Similarly, during this interval the speed is 15, suppose, so in 1 second it will travel 15 meter. Here it was 10, so during this second it will travel 10. Here it was 5, suppose, so it can travel only 5 meter. So during first second, suppose a small amount of distance is traveled, during second it will travel double than the previous one, and in this case it would be 3 times, and in this case there would be 4 times. Okay, so let's see one by one, graphs one by one. So let's move to D part first. In case of D, like with the passage of time distance is not increasing or decreasing, distance is fixed. So when there is a fixed distance, like with the passage of time distance is not changing, it means the object is in state of rest. So this option is incorrect. Object is not in state of rest, object is moving with uniform velocity. So now let's look at option B. In option B it says initially the distance traveled is like during the first second, I think here is the first second. In first second much more distance is traveled than second, then third second, and then fourth second. In 4 second the, like suppose more distance like almost less distance is traveled. You can see the okay. So here is a suppose first second. So this is the amount of distance it is traveled during the first second. Suppose it's the second, third, fourth. So it looks incorrect, because during the first second the minimum distance is traveled. Now let's look at this. It's like the distance is increasing uniformly, like it means equal distance is traveled in equal amount of time. So like we know that during the first second less distance is traveled, in second second more distance is traveled. So I think this option is correct, because you can see during the first second here minimum distance is traveled, and during the first second, like the first second, like comparatively large distance is traveled, and in third second you can see from here till here comparatively more distance is traveled, and during the last second much more distance is traveled. So for me I think this option is much better. Question number 13. When a heavy coin falls towards the ground, when a heavy coin falls a short distance towards the ground, it does not reach terminal velocity. Why is it so? The first thing is, like object achieves terminal velocity when friction force, which is air resistance, becomes equal to weight of the object. Until both are equal, like the object, like there would be no terminal velocity. When friction force become equal to weight of the object, then we can say the object is moving with terminal velocity. The first thing is, like there is a short distance. Second thing is, like the distance is very short. Second thing is, maybe like the weight and terminal velocity are not equal. Like for terminal velocity, weight and friction force must be equal, but if the object does not reach terminal velocity, it means weight and terminal velocity, weight and friction force are not equal. So let's see the option. The coin has not hit the ground. It doesn't matter whether it hits or not. The weight of the coin equals to air resistance. So when weight and weight and air resistance are equal, then it will have terminal velocity. So it's incorrect. The weight of the coin increases as air resistance increases. False. So the weight of the coin is always more than air resistance. Yes. If weight is greater than friction force or air resistance, then we would be lagging some terminal velocity. So we would not say that we have achieved the terminal velocity. So for terminal velocity, friction force and weight must be equal. A car now 14 number. A car travels along a road at 50 km per hour. The driver applies the same braking force at the same place on a day when the surface is dry, and on a day when the road is wet. So when the surface is dry, it means the friction force is there, as more friction force is there as compared to wet road. So when there is a wet surface, then friction force decreases. Friction force decreases means when a driver applies brakes, the car will not stop at the same time, but it will travel some distance, that is called braking distance. So it says on the surface how many of these distances are greater than on dry surface. So thinking distance is related with your approach, your mental approach. It has no link with the with ground, so it's wrong. Stopping distance, braking distance, only friction is affected by braking distance. Okay.